Where's my phone? Don't need phone. Okay, let's get started. So today we have a pile of MacBooks that no longer work. And with any luck, we will get these to work again. So first one on the list is an A1708 with liquid damage that apparently does not turn on. So the first thing to check is what we get on a few power rails when we plug in the charger. So we're going to plug in our USB-C charger. The first rail we want to check is going to be PB3_G3 hot. So that is a rail that is going to come from U6990 if the enable from the ISL is present, and that is going to show up right around here somewhere. Another quick test we can do is check voltage on PB_G3 hot, and if we have G3 hot, we know that we have if we have PP-bus, we know we have 3v3G3 hot. So PP-bus G3 hot is 13 volts. So 13 volts is normal if there is communication with the battery lines. The battery communication lines. And let's see, is vCore there? CPU is a little bit warm, but not warm enough to indicate post. No vCore here. No vCore here. And this isn't good. We have corrosion near our system agent regulator. That is 0 volts. About right here. That's actually present. This might have a chance. That's not posting. So let's have a look here. So we're going to open the board view for an 820.00840, which is a 2017 or 2016 A1708. We see our corroded part right here is going to be U7370, and that's actually there is no voltage coming from U7370, 0 volts. Now this isn't good because if this stops switching, our PCH is likely dead. PCHs on these are going to be integrated into the Skylake CPU. So what we're going to do is check diode mode to ground. That should be about 23 ohms there. Let's see. 25 ohms, that's perfectly healthy. What about on CPU vCore? 13 ohms, that's good. Check all phases. 13 ohms. What about GPU? GPU is probably going to be closer to 0. Yep, 5 ohms. 6 ohms. Okay, so with this being said, if this got hit right here, this most likely killed our ISL on the other side of the board. Now if we look at our ISL, we notice we have a little bit of corrosion right here. It's nothing too bad, but liquid still got here. So I'm going to go ahead and remove this edge bonding. Now liquid can't really get to this chip, or at least not a lot of it, because of the edge bonding. However, if there's still a spike from one of the MOSFETs getting hit, this can still get damaged, and this is most likely damaged. So what we're going to do is go ahead and remove this edge bonding. Replace all of this messed up stuff right here, just mainly that cap. Let's check it real quick to make sure it's not shorted. I don't think it will be. That's not shorted. And then we'll see if it works, and if it works, then great. If not, we'll go ahead and do some more in-depth troubleshooting. So I don't want to leave the heatsink on this when I'm working on it. I'm going to use a smaller heatsink on the CPU, because what this is going to do, this heatsink is going to be in the stream of air as well as the heat pipe. So what's going to happen is it's actually going to transfer heat right to the CPU instead of pulling it away like it's supposed to. So let's go ahead and take off this heatsink first. And this was ultrasonically cleaned before it got to us too, which is a no-no. Don't do that. Ultrasonicing stuff before you send it is not nice. Where is, let's see. Cam is here, Joshua is here, Caroline is here, Polly is here, From the Ashes IT is here. A bunch of people are here. So our heatsink is off. Notice that obviously the thermal paste has been reapplied as expected because someone ultrasonicked it. So we're going to go ahead and pull that one MOSFET off as well as the messed up stuff around it. These are going to be good. Those don't look bad. So let me go grab a heatsink or a couple heat sinks. Yes, indeed. People that ultrasonic stuff will get a temp fee if they make it worse. It honestly gets old. It's, the thing is ultrasonicking stuff isn't fixing it. Yeah, it will work, but when a component is already corroded and falling apart like that, it's been damaged electrically. Yeah, it may work, but it's not going to work for long. And oftentimes when they fail after ultrasonicking, they tend to be a lot worse off than if you would have just left it alone. There's one heatsink here covering the main CPU die and graphics die, and here is another one covering the rest of the CPU die and the PCH die. And this is an SIC 532. There's also another Fairchild chipset that will work on this. I don't remember which one it is, but I know some of them have a Fairchild chipset. So flux. Hot air at 430 degrees and 100% air. And of course, my tweezers are not here. Where are my tweezers? Here are my tweezers. I think this was okay. I mean, I don't think the MOSFET was good, but I think the CPU survived. But there is going to be one way to tell. It's if it works. So I'm going to put a little bit of leaded solder down to assist in wicking, as always. Give me 1 second here, actually. I will be right back. I'm not going anywhere, but I have to do something real quick. Hmm. Okay, I had to reply to some messages. So we're back. So what's next? I have to wick this. Place a new MOSFET, capacitor, and resistor, and then change the ISL and the messed up stuff around the ISL, and just maybe this will work. I like MacBooks that work. A non-working MacBook is no good. Also, I have to figure out what I screwed up with my website. I probably have to break away on stream again because someone is here. I am back. Chris Long is here. MacBook came in with an exploding battery. It actually bent the bottom case completely up, which is pretty interesting. Flux. Did I leave my audio on? I hope not, because now I have to remove the video for phone number and stuff. Did they take a candy? No. I don't have candy. Local's starting to gain some ground. I just have to get my name out here and, you know, kind of take back the third-party market from people that have kind of and that's too much there. Okay, good. Audio is muted. I kind of want to stab that battery now. Seems like it would be a fun thing to do. Chris, have you checked out, so you know the machines with the crashing from the MOSFETs? Remember you asked about one a while ago if I had it, and I only had like 3. So you don't have to use FMDF 6808s. You can use 6708s, and those 6708s are available from DigiKey and Mouser. So that's a more viable option than getting them from, you know, scammers like L2 and of course the printer waited until the customer left to start printing the darn server support. Get out of here. Stop. Cancel. 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 Stupid printer. Stop. Printer, your purpose is to print FedEx labels, not this nonsense. And it's printing a 3rd page for no reason. And it's printing a 4th page, the same thing for no reason. I hate printers. When printers break, I am not even messing with that. That is going to go right in the trash. And I'll get a new one. Printers are like $40. Okay. Cam, what is wrong with you? Who boils rice? What kind of a person would boil rice? I didn't know you boiled rice. Seems a little odd that people would boil rice. MacBook. I don't like to put more solder than what's required on these pads, because these are not something you really want to bridge. I hate soldering these power packs like this. I don't know why Apple went to these, and a lot of manufacturers went to these. Razer went to these, Lenovo went to these. I really don't know what the advantages these are over just regular MOSFETs, because these suck. I mean, this is more like a PMIC than anything. If you don't boil it, I don't know. I don't know how to cook. I wasn't aware you boil rice. And that is good. Let's clean this up. I don't get why people with no power, they jump to charge port. No, your power issue is not charge port. Your power issue is motherboard, not charge port. Don't change charge port. Change charge port on MacBook is like the new rehot. Did I just knock off a cap? I sure did. The soldering on these A12, these A1708 boards is really lousy. Look how I just knocked it off cleaning. This happened the other day too. What the heck? Where did that come from? That's unusual. That just came out of nowhere. Replace charge port. MacBook no work. No power. No green light. Customer spilled liquid on it. Replace charge port. No, it doesn't work that way. Now, what a lot of that is it's hopeful thinking. It's like, you know what? I think you don't get to choose your problems in life, and what I think a lot of people get carried up on, they like to choose their own problems. So they assume, you know what, I'm just going to imagine that it's this problem, and I'm hoping it's this problem. So I'm just going to think, you know what, it's just the charge port. And look what happens. Never the charge port. Get a meter and measure the DC in fuse. If you have 16 volts there, it's not bad. Go into place, little MOSFET. Go into place. There we go. Hopefully that's not bridged under there. Ah, look what I just did. Now we have to lift it again. I'm an idiot. I don't know how to do board repair. I'm just an intern here. If I told people I was just an intern, they would believe me. Where's the manager? I want to speak to your manager. You can't be the manager. You look too young to be the manager. I want to speak to the boss here. Who's the boss? Because I came in 4 months ago and you looked at my computer wrong and now it doesn't work. And someone else might be here. So I may have to cut out again. Nope, not here. Store next door. Hopefully I didn't float the CPU. I don't think I did. If I did, it didn't deserve to live anyway. But now CPU is fine. And we could confirm the CPU is fine. Chris, I like my high air temperature. This is how we do things here. 100% air. You're just jealous because your AOE unit or whatever it's called can't go up that high. You're just jealous, Chris. Let's check resistance on CPU vCore, and we're at 2 ohms. That was 20 ohms before. That's not good. It's still hot, so that can be normal. When you get something that hot, the resistance tends to go down a little bit, so once you let it cool, it will usually go up to normal values again. But let's see. CPU isn't that hot, but 2 ohms. Now it's back up to 3 ohms, so yeah, 3.6. If we just watch it on the meter, it's going to go up 3.7, 3.8. Whenever you get heat near a CPU like that, measure resistance, compare it before and after, and it'll go up to normal again. We're at 4 ohms, we're good. 4 is officially fine for Skylake. Everything else looks good here. This a little bit melted, not bad. No signs of popcorning, so I think we're good. Let's take out the SSD. SSD is not something I want to float because that might make someone a little bit mad at me. And let's take off this edge bonding on the ISL 95828. How I do these is just a blast of 430-degree air. Until you see it lift on the corner like that. And after it lifts on one corner, you can usually just pull this up. Like that. See that? The chip looks fine, but we're going to change it because it's probably not fine. Rehot NAND. That is an excellent idea. Rehot PMIC. Rehot charge port is an even better idea. Rehot everything. We can even rehot LCD. No image? You know what? Rehot LCD with no image. Who needs an LCD? Wouldn't surprise me if some genius actually tries this. No, there's probably that one person that's going to see this and say, just like the whole free help joke, if anybody doesn't know this, but I removed it by now, but it was a joke I was posting on Discord and in Lewis's chat, and it's a free help thing. It says free help 24/7, 365 days a year, and what actually happens if you email that, it emails my friend that also has a shop. So people were actually thought I meant free help by that, and I got messages saying, I saw you provide free help and this and that. It's like, are you kidding me? You know, I just don't understand how you don't get that that was trolling. It's just beyond me of how someone could really legitimately think that that was not trolling. So that's what I mean when I say someone is going to see this and then, you know, oh, you know what, he said rehot LCD, I have no image. You know what, I'm going to take my blowtorch and, you know, just heat LCD. Wouldn't surprise me. That looks good. We'll fix that resistor later. I'm going to clean this old flux up. We're going to solder a new ISL 95 whatever it is. There's a good chance the CPU may be dead too, just so you guys know. In that case, I'll move on to the next MacBook. I have a huge pile of stuff to fix today. People believe CNN, so people believe everything. That is absolutely right. Caroline says, rehot battery to fix. I think that is an excellent idea, and I actually have. Check this out. Look at this. This came in like 20 minutes ago. Yeah, that. Probably not a good idea. I have to bring that and get rid of that today. Sonia's here. In reality, if you stab those cells that are all bloated like that, nothing's going to happen. I've done it on purpose. Whoa, look at those solder balls. Clean, you guys don't belong here. Get it out of here. Those seem like they're gonna cause some trouble if I leave them there. Hence why I should not leave solder balls there. How is Sonia not a mod here? I thought I made you a mod a long time ago. I could have sworn. What? I don't have an option to make people mods? I can't even make you a mod. Like other users show up, add moderator, but yours doesn't. It just says go to channel, report, remove, put user in timeout, and hide user on this channel. There's no option for moderator. That's really strange. Nate Parker is here. And Nate's Tech Services. I don't know if that's the same person or not. I think that's good enough. I've seen these chips reworked by Apple before, and they were terrible. They used like the old edge bonding, so it wasn't even stuck on there. And there was flux around here, and I know it was an Apple refurb board. They said they brought it to Apple, and they replaced the board. So I know it was a refurb. There was flux around the couple areas around that. The leads had probe marks in it from them probing. It was pretty cool. And you know, want to know what the fault on that board was? There were several areas on that chip that didn't have enough solder, and the joints cracked on it. So I put fresh solder on it, and it worked. I'm going to let this cool, and we're going to try it, and let's see if we get a 21st century fan spin. I think it's cool enough by now. We're going to plug it in. If we get V-Core, excellent, it's fixed. And if it doesn't, I will cry. "13 volts on PP bus, 0 volts on graphics, 0 volts on V-Core. 0 volts in system agent. Okay. So now we have to check our power rails. So let's see. We took care of what was obviously corroded. It's not that anymore. So PP5V underscore S5. PP5V S5 is going to show up near this U4000 thing. And we could find that on right here. PP5V S5 is 5 volts. PP3V3 underscore S5 will show up over here on this big coil right here. And that is 3.3 volts. Now PP5V underscore S4, which is going to show up in the trackpad area. PP5V S4 powers the trackpad. At least one of the sub-rails of it does. But for this, we are going to, where is this? It's over near the RAM, and that doesn't exist on this board. Imagine that. Wait, yeah, it does. Right here. PP5V S4 is 5 volts. PP3V3S4 going to show up in our Wi-Fi area over here. Is 3 volts. We're entering an S4 state. We're going to jump ahead and cheat and check SO now. PP3V3 underscore SO. That is also going to show up near our Wi-Fi area, right over here. And that is 3 volts. So we're actually entering SO. But we're just missing V-core. So most of the times when, let's check 5VSO real quick in case there's a short on one of these caps. I kind of doubt it will be though. But in order for any of these to work, they need 5VSO, and that's the thing with these stupid, that's there. With these stupid PMIC like regulators, you need all this stuff to get them. So this is going to be more of a missing V-core issue now, but wait a second. Usually we will have either V-core or graphics voltage, but not one or the other. We have all three, GTVR missing, system agent missing, anything that's controlled by our ISL is missing, which isn't good. So let's check one more thing, PP1V8SO, because this powers our PCH, and if the PCH isn't being powered, that's not going to send voltage to, that's probably going to screw up communication with PP1V8SO. Is 1.8 volts. Okay, so we're going to go ahead and check a few things around this ISL. This is probably going to be hopeless because the CPU is probably not sending out the serial communication to tell the ISL to turn on, but let's see. CPU VR VIN, which is going to come from, what does that come from? PP bus. Let's check and see if we get the VIN, because if we're missing the VIN, then nothing is going to work. So our VIN is going to come in right here. And that's 13 volts, so we have that. PMEN CPU VCCR. Let's see if it's getting told to turn on by the PMIC. And it is being told to turn on. PMP good. CPU VCC, which is going to be a PCH signal saying, okay, CPU is okay, go ahead and send vCore. Is 0 volts, of course it is, so we don't have the P good signal for CPU. I think that's what our issue is going to be. So let's have a look more in depth at this rail. First, let's check. Yep, that's there. That's going to be pulled down internally by this chip. PDF search R7140. And that's going to be derived from PMIC signal, which is right here. That actually doesn't come from the CPU, that comes from the PMIC. Let's find this because I'm a little bit confused here. Okay, so here's our resistor for that. So what do we get on? So one side of R7874 is PMIC ENH, whatever that means. That's 0 volts, and on the other side of that is CPU P good, whatever. So this is where it's going to be coming from. We actually got a pulse. So kind of what I'm suspecting is there might be junk under the PMIC. Now, is this an underfilled chip? I don't think so. It is not. So what we're going to do is go ahead and give this a reflow, a full reflow to where it's, you know, fully liquid on its balls, and maybe this will work. So we know we kind of have a PMIC issue, but of course there could be an issue with the CPU as well. But I'm going to go ahead and put some flux around this to clear the junk under it, and hopefully this will work. Because I really don't want to reball this thing. This is why ultrasonic cleaning is just evil. Sonia says, just an FYI, you and Lewis are both full mods on channels when I go live. Thank you. No problem. Thank you. I could have sworn you were a mod here, though. Here and now the option is there. Before it wasn't there. And I could have sworn you were a mod before. I don't know, YouTube is weird. So we gave this PMIC a little reflow. If this doesn't work, it's probably a CPU issue. That PMIC really doesn't die much. It's more of just CPU not sending out the P good signal. The CPU has to talk to that, I think. I don't know though. Let's measure vCore now. And it's still 0 volts. Okay. Next. No fun. The next one. Ticket number 4578. MacBook board repair. Error 2011. Uh-oh. Error 2011. Error 2011. That probably beeps. (2011) error beeping. Behind door number 1 is a cracked ball under RAM. Behind door number 2, dead CPU. Behind door number 3 is liquid damage and or missing a power rail for DDR regulation. First off, let's clean our work area a little bit. Never good to work in a dirty work area. I don't understand how people can keep such a dirty workbench. Mark Prince is here. Let's grab a screw holder. I'm going to give you slot 13. And buffering isn't my problem, that's AT&T's internet. Where's my screwdrivers? Here's my screwdrivers, but it doesn't solve the problem of the one that I need, which was sitting right here a minute ago, and now it's not here anymore. I swear, my Pendulum 5-bit was right here, and now it's not here anymore. I need a screwdriver set. Constantly losing stuff. Yeah, AT&T internet is absolutely terrible. That's a T3. P5, here we go. I put it in the wrong place. Yeah, AT&T, so one, they took forever to install it. It was over a month. They swore they had service in here. They didn't have a fiber line to the building. So they have DSL lines to the building, but it's against their policy to give me DSL if they have fiber capabilities in the area. So instead of just turning me on the 15 up and 5 down, 15 down, 5 up DSL, they said, no, that's against our policy, so you know what, you're going to have to wait for fiber. I waited over a month for them to finally run fiber from the street over to the building, which is just absurd. Oh boy, this is going to be fun. I already see stuff. I've already seen signs of someone messed with this poor MacBook. What did you do? You touched poor CPU, didn't you? What do you even do? Yeah, the AT&T fiber is nothing special. Trust me, it is nothing special. Is it still buffering? Let me type in chat because I don't know. And it beeps. That is MacBook self-harm right there. That is a MacBook's way of saying, I don't want to live anymore. I don't want to be a MacBook anymore. So I'm just going to start beeping. Gotta get gloves. Yeah, it's either going to be AT&T Internet or YouTube for buffering. So, beeping. What causes beeping? Several things. So, actually, another issue that can cause some of these is a corroded LP8550. So we're probably going to remove the LP8550 too, because that can actually cause RAM beep. The LP8550 has a couple data lines that are shared with the RAM. So and I've seen this happen without any liquid damage too. Sometimes the most common random LP8550 failure is not no backlight. It's actually going to be beeping, at least on the air boards. And look, you put the big screw in the short hole. That was mean. I don't get why people are so mean to poor MacBook. This poor MacBook did nothing at all to deserve someone being mean to it. Wi-Fi antennas, and you put the big giant screw in the heatsink where the shortest one is supposed to go. Why? What? This huge screw. I bet there's a hole in the top of the case over here. There isn't, luckily. I thought for sure there was going to be a hole there. That's right, there's a screw under the SSD on these. Take the screw out. Beep is not good. Beep doesn't mean brain. Okay, beep means brain saying help me, is what beep means. So, let's have a look here. So, behind door number one is a cracked ball or bad RAM chip. Behind door number 2 is a dead PCH or dead, where is it here? CPU. Behind door number 3 is a missing power rail to our RAM. And behind door number 4 is going to be a you have liquid damage. Someone hurt you. And what are you by? What in the what did I just say? Liquid damage. Look, liquid damage, LP8550. Liquid damage, LP8550. Liquid damage, LP8550. This is a different board, Chris. The other board is probably hopeless. That's why I moved on. So, what we're going to do is take off the LP8550 and see if this chimes. So the triangle thing is in that corner. And this was a board the customer bought as a replacement board, and it did the same thing. This is why, you know, when I see someone... Oh, wait. Was this the LP8550? Whatever it is, we probably don't need it. People buy these refurbished boards on eBay thinking they're refurbished, and what they mean by refurbished is we cleaned it. And I'm so sick of this when a shop says, oh, we fixed liquid damage with our ultrasonic cleaner. No, you don't fix liquid damage with an ultrasonic cleaner. You clean it, and that doesn't mean it's fixed. You know, it's... Cleaning isn't the same as actually replacing the damaged components. There's probe points and a lot of other stuff. And I've been getting more of these, and it's starting to really make me angry when I get them. Alright, what do we need? We need speaker. speaker. We don't need a screen because we know we're not going to get backlight anyway. Speaker, I/O board. Charger, plug it in. Are you gonna beep? Are you gonna chime? Of course. Hi, what's up? Let me see. So on both of those that I see, let me see. On that, in that case, what I would do is just grab. Do you have any pair of wire cutters, either X-Lite 170M or CHP, whatever these are? I don't know what CHP 170 or X-Lite 170. What you're gonna do is grip the base of that screw and turn it with the wire cutters. That's what I would do. It'll work. It'll work. Yeah, no. If you use the wire cutters and turn the head of the screw, it'll come out. If it doesn't, what I would do is take a Dremel with a cutoff wheel and just notch it, and then take it out with a flathead. Either one of those will work. I don't think so. It just as long as you're careful, with it, it should be fine. No worries. No problem. Bye. Okay, so it's not the LP8550. We know that. So let's plug it in. Let's take the DC in board. Let's check our RAM power rails now. And then it's time to smoke up the office with flux. Okay, plug in DC in board. So, DDR, what do we need? We need like one, I forget what it is, but we need a couple of rails to get DDR power. So first things first is like 1v2 or whatever it is, it's going to show up on these caps. .5 volts, 1.5 volts. Anthony, this is a MacBook, stop trolling. .5 volts, 1.5 volts, 1.5 volts. I think we're good here. Let's check. What board is this? This is a 3024, 3023. Actually, I'm not the one to tell Anthony to stop trolling because I constantly troll him. So yeah, he could troll. 3023, not 3024. Here we go. And our DDR power rails are going to show up. Let's see. Let's look at the schematic. Where are they? Here we are. So where is our DDR? So PPDDR, whatever VTT, whatever this is, we need this. So we're going to check this first. And what? Paul's software didn't even pull it up? Paul, what's up with that? Come on. Look, they used to work. If I click that, it used to show up in the software. And now, here it is. So PPDDR, whatever, right here, it's going to show up. On R3303. And VTT DDR-S3 is 0.7 volts, and that doesn't sound right, I don't think. I don't know if 0.73 volts is right on that. That should be higher, I think. I'm not 100% on that, but I think that's I don't know. What is that supposed to be? The schematic should say. I'm being stupid. Where was it? No, that's right. 0.75 volts. Yeah, so at this point, it's time for flux. Actually, it is not time. So what I could do is be an idiot and reflow the RAM chips without first having checked other stuff. What I mean by other stuff is the stuff that was corroded. So let's just see. Maybe this is for some data line or something, these two corroded probe points. So let's go ahead and check what those are for. So that's going to be near a diode. Where's this diode at? LCD backlight feedback, I2C, I2 squared, whatever. T29, that's Thunderbolt. And thermal trip, I don't care about thermal trip. And Thunderbolt, yeah, I could care less about Thunderbolt. So what we're going to do is start reflowing the RAM. What I'm going to do is heat this area up so just get a nice preheat on it. Because I don't want to put this in the oven. I'm lazy. Let's, Anthony, this is actually beeping. So, a little bit easier than no post, but it's still the same thing. We're going to heat this up. I just took the fan off so I wouldn't melt the fan. Get a nice preheat on this area. Chris, I don't know if anyone does, but I know there's a ton of configurations that if they're wrong, it won't work. Send Brendan Henry a message and ask him, because he knows more about this stuff than me. So we have a nice preheat on these now. Time for flux. If it's liquid damage, there's always a chance that there could have been corrosion under this too. So, we have a nice amount of flux here. Let's get our fume extractor up nice and close because it's going to fill the room with smoke. And we will start on the reflow. I really hate doing these, there's just so many chips. The good thing is, once one is reflowed, the board is hot enough that the one right next to it will usually go just fine. There's one. There's two. There's three. Ah, this stuff. Get out of here. Oh, shoot. I screwed it up. Let's take this off. I'm an idiot. Look at this. We're going to try and move you back. Actually, you know what? We'll fix you and put you back in a minute. That foam stuff will get under the balls and that's no good. One. Two. Come on, reflow. This bank is done. On to the next bank. Come on. So now we have to fix this one, which is not going to be too fun, but most of the balls look okay. So we're just going to fix this up real nice and put the chip back on. So what I have to do here is clean up the bridges. This is NC559, which doesn't really wet lead free all that well. So we're going to put some 213 in here, which does wet lead free. Kind of mix it so it has some lead free wetting abilities. Chris, what size balls are these? Oh, my back hurts. I gotta get a new chair. Tim says I am not an imposter. Alright, let's see. 0.35, I think. Should probably buy a new office chair today. Try 0.30s. Way too small. What was I thinking? Use 0.40s. Tim Herman is the imposter, not me. I am lots of things, but an imposter is not one of them. I am the original. Established in 2016. Need another pair of tweezers. .45. I'll use 0.40s then, because yeah, I'll use 0.40s. Because there's still some left on the pads. Oh, you know what? Do I have 0.40s? 0.5. These 0.4s. 0.6, 0.65, 0.50, 0.40. think these are a nicer match. I've never gotten how solder balls are so jumpy like that. I just don't understand why they're like that. It's like they cling to everything. One looks too small. Chris, pick up a tube of Amtech VS213-A. You'll like it for reballing. Pure Novice here. Pure enough. See what I screwed up? Pure is a smart guy. He knows way more about boards than I do. I have to clean this flux up. I'm setting up a second station here, and hopefully I can get someone that can do this so that when I screw stuff up, there's someone to help fix it other than me. Because that's the whole point of this is, you know, you screw something up, you pay someone else to fix it, because I don't want to do this. Yeah, I agree, it does burn off a lot faster than 559. But 559 does not have lead-free wetting capabilities. 213 does. I still use 559. Another thing about 213 is it is not cleaned off by the ultrasonic cleaner. Whatever's in it is non-soluble by Branson. So, I use it in small amounts, or what I do is dilute it with 559 so that it's mixed with something. And if it's mixed with something, it will be removed by the ultrasonic. Yes, I agree. We all need our own Paul S. Does anyone seriously know why the solder balls jump so much? I've never understood that. Ah, come on, really? I just created 3 times the work for myself. Don't you love creating 3 times the work for yourself? Always extremely fun to do extra work when you could be working on something else that you can make money on, because this is probably going to have a dead CPU anyway. Why 42 volts, Anthony? I saw you post that on Discord too. Why not 58 volts, or 64 volts, or 12 volts, or 188 volts? No, no, you don't. You stay right here. There we go. It's easier, I guess, just to hold the ball. From the Ashes IT is here. One more right here. I want you to go liquid. Go liquid. Come on. There we go. I really hope this works. I think it will. I don't know though. I lost that ball. Yeah, RAM probably isn't that hard to reball. I just don't have a stencil. That's why I'm doing this. Thank you, Sonia. Three to go. My Quick is just about 2 years old now. Two-years old, and who knows how many boards fixed with it. A lot. There we go. Let's have a look, make sure there isn't any that we missed or any that are super big, and there is one that we missed. Otherwise, this looks pretty good. Just one right there. That may even be an NC. Have you had to replace the heating element? Nope, not yet. With the bent nozzles, it sucks. The temperature coming out with a bent nozzle is like 360 degrees at 430. But a lot of that is just in the bent nozzle. It loses a whole lot of energy going around that bend to the design of them. If they had the way their bent nozzles are is they're just slanted. They're not curved. If the nozzle was curved and just designed a little bit better, it would be a ton better. But due to the design of it, there's a whole lot of energy loss. But no, with the big nozzle, the heating element still works awesome. Feels like new. Heats up quick, doesn't. So we're good here. Let's grab our RAM chip. Wick the bottom of it. Yeah, that wouldn't have been the best idea if I put this back on. I'm actually not going to wick it, I'm just going to leave solder on it like this. That'll be fine. Gonna put line of VS213 just to increase the wetting abilities of 559, and then some 559. We're gonna line this up. Go 430-30 and slowly add heat from far away because this thing is going to want to jump. We have to maintain alignment too. Surface tension will take care of it for the most part. But we just want a nice slow heat. No, you come back here. Okay, it's on some of the balls. There we go, it's in place. Look who it is, Mr. Drill-A-Lot, says Bailey. Anthony, I didn't refloat it. Well, I refloated earlier, but I just put the chip back on. Yeah, my back hurts. Everyone says that people my age should be able to do things like what I did the other day, and yeah, no. I spent several hours on my, well, 2 hours on my back, on the tar, underneath a truck, doing stuff. And yeah, I feel like I'm 60. Okay, do you chime? Do you beep? What do you do? If you chime, I'll be really happy. Please chime, little MacBook. Green light. It chimes! Okay. Let's put our backlight driver back. You're gonna go for a nice little bath. I could tell you what past 60 feels like if you want. Yeah, I kind of feel it right now. Everything hurts. My legs hurt, my shoulders hurt, my neck hurts, my back hurts. I'll take this. Isn't that bad though. I don't care about how my back or my legs or my neck feels, but anything with the hand, no good. I had cellulitis on my hand, especially like on my knuckles and stuff, and let me tell you, you do not want that. That sucked. Because you can't really bend your fingers because the skin is so tight. And I was out for 4 days on that, and yeah, no fun. I'm still getting caught up from being out for 4 days. Was this the LP8550? Yeah, it was. What am I thinking? Of course it was. Let's clean this up. Grab a new LP8550. I have 2 left in this spool, and then I have like another spool of 40 of these things. Been doing much iPhone work? Actually, I have 2 in right now for data recovery. Both I'm not looking forward to. One is boot looping, and the other is water damage data recovery. The boot looping one is just going to be terrible. First things first, I'm going to try a new battery. It's a 5 too, with history of no charging before boot looping. So yeah, it's probably, if it's a TriStar, I don't know. Yeah, it's right by the CPU. I don't really want to do that. Is Chris still here? Chris, do you want to do a 5S TriStar? I mean a 5 TriStar? Because I'd rather send that to you, because I don't want to do it. we go. You just went into place. Yeah, the one by the CPU. It's not bad. Do you use hot air or put a blob over it and take it off? I guess it's really no different than working by the NAND or something. And I've worked by NANDs before and I haven't messed anything up. What do we need? Who's messaging me? Computer's too slow. Hot air and coin on CPU. Okay, let's plug you in. Let's see if you have backlight. For all we know, though, the heat messed with the CPU. And what the heck? 480 number. Hi, how can I help you? Yeah, how can I help you? No, not today, though. Appreciate the offer. Alright, thank you, bye. No, I don't need help making my phone ring more. It already rings enough without your nonsense marketing. Get out of here. Okay, so this is working. Let's wait for question mark. But yeah, I fixed it. Question mark? Come on, show me you have image and VRAM's not screwed up. Question mark. Come on. Question mark. Fixed. Now you need to go for ultrasonic. Remember I did my first iPhone 6 TriStar a while ago. And then I did another. My second one was on a 6 Plus, I think. And what's funny is that 6 Plus was fixed and it just came back not too long ago with a 1v8 short. So this had a cracked ball under the RAM, most likely. I could care less about the Thunderbolt corrosion. But we replaced backlight driver. You know what, let's inspect that area just in case. And look at this. So this is Apple thermal paste. This is Apple original thermal paste, okay? And they put this in the ultrasonic cleaner, the so-called refurbished board. Yeah. Board repair over refurbishing all the way. Where was that other probe point I saw? Right here. Right here looks nasty. Hi, how can I help you? How can I help you? Someone in live chat is screwing with me. Who was it? Alright, so this resistor right here, where was it? I don't care about you, Thunderbolt via. I don't care. There was a resistor somewhere here. This one. This one is seen. Why are you tinning the test points? Because they're corroded and nasty and I don't want them to come off in the ultrasonic cleaner? Let's clean the thermal paste off the CPU. And ultrasonic time. Don't need solder balls anymore. Heatsink. What did I do with the screws? Oh, here it is. I'm just going to stick that there. This is trash. I like to always straighten my work area up between repairs like this. It really helps, because a messy workshop is just no fun. Okay, next one is board repair. 820-3332 does not turn on. Let's see what's wrong with 3332. Let's grab a screw holder because we want to put the screw somewhere. We're going to give this one slot 17. And we need our P5. Let's jump right into this. What? No, this is no good. Please, please stop doing this. Look at this. So, what do you see here? You see a screw, a big screw. Then you see the wrong screw right here, and then look at this. You see even the worse wrong screw right here. Please put the right screws where they're supposed to be, and then the other one is right over here. Come on, guys, seriously. I don't care. Please put the screws where they're supposed to be. The screws need to be in the right place. You could long screw these boards just like you can iPhone boards, and it's no different. It's not even that hard. Just remember, take pictures, do whatever. Just put this poor screw where it's supposed to go. I'm going to take the board out, SSD out, as always. Take this darn wrong screw out. Your MacBook will be happy if you put the right screw where it's supposed to be. MacBook will not be happy if you put the wrong screw where it's supposed to go. Yes, Caroline, that is exactly what happened. Someone said screw it and send to TCRS, as what everyone says. That seems to be a fairly common phrase. It's just screw it, send to TCRS. Everyone says that now. Okay, so what do we see here? We see someone's been here, someone messed with MOSFETs, and the area of the board under the MOSFET is coming up. So that's a potential problem. Let's have a look near ISL. ISL has crooked and has a wire running under it and has a crater. Okay. Much fun. Much fun. So, what is blown on here? So, if we look, this is going to come from what? So, let's go switch that side of the ultrasonic. I mean, switch the board in the ultrasonic. Have to remember not to leave them in there that long because we're running at a higher temperature now. So, I want to say this is going to be charger something or other here. So open 3332. I don't even know if I think I'm out of those MOSFETs. I haven't had to do one of these in a long time. Probably take them off at 2915. So charger phase is what got screwed up. Now what I'm thinking here, so for one we could have a bad L7030. Secondly, we have blown current sensing resistors. So let's plug it in. Let's see what we get. See if we get fan spin. Hopefully there's fan spin. It's on no post or anything. We get no light on the charger. Oh wait. Yeah, we get no light on the charger and no fan spin. So we're going to measure PP3V42 because we can't really get fan spin if we don't have PP3V42. PP3V42 is going to show up, where is it? It's around here somewhere. Yeah, so it's going to show up right here. And that's there. So we have an ACOK issue or something like that. And I already see the problem from here. So who in chat that's here can show me what the problem is right here? Who sees it? Who sees the problem? There's a hole in that resistor. Open line. Where's our other ones? Right here. Normal, open line. So we have an issue right here. Now, I don't trust this at all whatsoever, so I'm going to take this off because if this is, what wire is this for? What wire is this for? So charger Elgate, yeah, that's not, you can't really solder. I bet you don't even have connection to that MOSFET. And one, that little tiny wire isn't going to be able to support the current. It's just going to go explode as soon as you turn it on, once there's a load on it. So oh man, this is bad. That's not good. So you see how this is all blown out right here? The problem with this is there's still going to be a short in there probably. So what is this? There's another layer under here, and I don't know what that layer is. So is this ground? Please don't tell me this is ground. It's not ground, so I think we're good. We're not going to touch anything right here, but we can't just drop a chip on top of this. It's going to short, and that's why it wasn't working, is that layer, you can't just put a random signal to a random layer in the board. I think that's PP bus G3 hot. So yeah, if you're just putting charger L gate to PP bus G3 hot, it's not going to work. So what I have to do here is, of course, run a jumper to that, but I'm going to have to put a few layers of conformal coat here after that, and I'm also going to peel up this trace just a little bit. Yeah, you know what? We'll just break you off right here. We don't want to touch this. It's not shorted to ground. It's not hurting anything. So we'll just coat this up. Several layers of conformal coat. In the meantime, let's wick this up and prepare it for soldering. So what I mean by that is just little flux. .1:30, it's almost time to start packing stuff up to get to FedEx by 4:30. And someone is complaining. Hopefully those MOSFETs are good. I think they are, but then again, you never know. We'll find out soon enough. Go take that board out real quick. Put it in the alcohol bath, displace the water. Then we'll dry it off a little bit. Does anyone here reject repairs that are biohazards? Depends on how bad of a biohazard it is. Dog pee? No. Cat pee? No. Human pee? Probably. Vomit? Yes. Anything else? Yes. Happy healthy resistor. You're gonna go bye-bye too. I don't trust you.
right now, no chime, doesn't matter the board, cable, fan spinning fast, keyboard unplugged, and the power's down.
So I'm going to have to put several layers of the conformal coat down right here. And that stuff should be okay in the heat. That's why we're going to use several layers of it, because we don't want too much in here. This is not fun. I really want it to cure nicely, so that's why I'm just going slow with really thin layers. Come on. It's not really easy because it doesn't want to flow off the tweezers. There we go. Secure that. Where's my little light? Probably not here. Around 2:30, I have to stop streaming so I could pack up the outbounds today. So about 45 minutes left. And I'll probably jump back on. I think this is good. Yep. The goal is to have multiple layers, so if one gets burned off, you still have some protection underneath of it. That's good. Do one more layer. Now what we'll do is just run the jumper. I think we could run it under there too. It really doesn't matter. Work that out. But either way, I'm sure the V is busted. Charles Hall is here. Yeah, you know what? I think I'm going to run that jumper after the chip is down, and what I'll do is just try and stick it in that, not stick it in, but solder it to the nub of the chip. I've done that before, and I think that's what I'll do here. The flux is going to wash away some of that, that's why we added 3 layers. Just grab a new chip. I'm also going to check if my MOSFETs are shorted gate to source and stuff like that. I don't think they will be, and this looks like it was soldered by a monkey. I can't stand this when the ISLs are crooked. When I see someone do that, it bugs me. Yeah, don't do this. Unless you want me to yell at you. That's good enough. So now what I'm going to do is I'm going to run a little wire. We're going to probably have to go on the other side of the board too. Actually, first, let's fix the soldering on these FETs right here. These don't really look too good. I mean, look at this. Oh, you know what? What is this nonsense? Get out of here. Yeah, you know what? Come on, this... It's not shorted. We're gonna leave this alone for now, I think. It's just beat up really bad. That MOSFET just got so hot that it buckled this. They replaced the MOSFET, so... Is this capable of carrying electricity? Let's see. It is. It's not shorted to ground. Okay, this is okay. It's not the best, but I think we'll be okay. JDF, who's that? I don't remember adding a JDF moderator. Someone must have been screwing with my computer. Okay, and you see I soldered that like an idiot. It needs to be pushed up more because it's not aligned right. Oh, it's Wes. Hi Wes, how's it going? I think this air coming out of the quick is way hotter than 500C. I mean 430C. Look what it did to this chip. But this is aligned better now, so I think we're okay. What we're going to do is start the jumper here. This is a bigger grade wire, so if we have to carry charger L gate, we should be fine to the other side of the board. Come on, really? Now, where are my good tweezers? I had good tweezers. Here they are. Now we have to hold this down, make this look a little bit more professional, like someone here actually knows what they're doing. May have to pull the chip and run it under it. I really didn't want to, though. Making contact? Ah, come on. Most wires are going to be bigger than the original trace. Why would you be concerned about the gauge of the wire? Because it's kind of a high load line. Right, I'm going to do it this way instead. I've seen wires, people use too small of wires, and when you turn them on, it just completely, and I just poke tweezers into my hand. I should probably clean that. I've seen wires just melt from... So I'm going to try and get a nice little solder joint on that little nub of the chip. Because remember, underneath is kind of shorted and nasty, so we kind of don't want to go there if we don't have to. We may have to, though. I don't know. Come back, little wire. You're right here. Oh, this sucks. Why did I choose to do this with life? Come on, little wire. Okay, that's soldered semi-decently. Actually, who am I kidding? That's going to break right away. But now I have the length set right, so I could kind of work with it a little bit. Like that. And now what I can do, I'm going to turn my temp down a little bit. For like 540. I'm going to move this a little bit away from this other probe point here. I desoldered that on purpose because I can't have that there. And now that's in position. So I can touch that with the iron. And I think there's a joint there. And there is. So if we plug it in the charger now, what do we get? Still dead. What is on PP Bus G3 hot now? Zero volts on PP Bus G3 hot. Nothing at all. That's really unusual. There's 16 volts here. 16 volts here. Now, is the ISL even getting power to work off of? So, what is the ISL? The ISL is going to need... Man, this computer is so slow. I need, let's see, charger DCN and charger ACN. So charger DC, let's get this orientation right here. So charger DC in, which is going to go right here. 1 volt, no good. 1 volt. Okay, so how are we going to work if we don't have charger DC in? Now, where does charger DC in? Let's follow this back. So on this side of the cap, we have 1 volt. And charger AC in. Let's check AC in real quick. It's going to come up on all of these resistors and caps right here. It's 3 volts. Okay, so on one side of the resistor we have 3 volts. On the other side we have 16 volts. 3 volts, 0. Okay. Was a jumper soldered onto that blub when it wasn't meant to be? Yeah. That was like PP Bus G3 Hot or something, and they soldered it to the... Well, I don't know what it was, but I know it probably wasn't supposed to be there. And that's probably why it blew that resistor right here. That's why we obviously don't have a green light, because we're not getting the ACOK assertion. If we don't get ACOK, we're not going to get anything. Kick this error up a little bit. Now, in order for this to have a failure like that and blow that resistor, Q7085, or hang on, I have to check that. The inrush thing has to be changed, because obviously it's going to be blown. So where is this thing? Right here, Q7080. I think that looked really nasty too. Yeah, look at this. Look how hot that got. You can see the coloration of the pads. That thing got burning. Do we have that on this? Please have it. Yes. That thing, yeah, that's no good. That's why we're not working. Hopefully our new ISL isn't dead. I think it's fine though. I think that MOSFET is actually still fine. I just think it got blazing hot. So we are going to turn the board this way so we don't melt the keyboard connector. Go ahead and switch nozzles again. This ain't good. What nozzle are you using? I use the big one and then the little one usually. Rarely the small one. Yeah, that MOSFET's seen better days. Now, what are these pins for? Unconnected, cool. So this MOSFET is toast. I mean, look at this. It's welded. I knew it would kind of be like this one by the way it was coming off. Just ash. And I'm probably going to have to come back this because I got to start getting orders ready to go out today in a few minutes. I can scrape and get usable pads on this. My poor JSO2 though. Sad. This board has seen better days. Oh, I'm at 540. That's why 540 ain't gonna do it. 740, 840, 940, 1040. Not 740, not 540. Wow, it melted the copper. Look at that. That's impressive. Good news is there's still trace there, I think. I think the center one... Yep, that's the same, that's the same. This is different, but yeah, this is okay. It'll work. Just put solder down. It actually melted the structure of the pad. I'm gonna wick all of this. I'm sure that current sense resistor was toast too. There we go. And the diode. None of this stuff was good. And I'm going to insist that they get a new charger on this because, yeah, you know what's going to happen if you plug it into the charger this had? Same darn thing. It's going to explode. Let's go ahead and do our big FET first. And lovely, it's going to be a nice pain to solder because it's sitting uneven. I'm just try and get it good enough. I don't know why, but 3332s always fail like this. They're really susceptible to inrush damage, which is strange. Three 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 two isn't one of Apple's best. Have to improvise a little bit and put a lot of solder on these, so it kind of sits normally. I'm gonna solder the current sense stuff and everything before, I guess. Now we'll do our MOSFET. So I gotta hold it in position until it's soldered right. And I just dropped it. There goes nothing. There we go. I have a feeling this board is going to be a nightmare if it just screwed up. And we plug it in. Still no green light, still no fan spin. And the fan just fell off. Yeah, you know what? I do have a faint green light, I think I see. Still 3 volts. Okay, is our trace for DCN okay? Let's see. We're good here. But I bet yeah, you know what, screw this board for now. I gotta go. I have to pack some stuff up, get it to FedEx, and then I'll probably be back on this board a little bit later. So thank you guys for watching, and I will see you in the next one.